Hello friends, welcome to my channel. We have a problem of definite integration. So we have to compute the given integration. This is problem related to uh, definite integration. So we have given integration is 1 to infinity x square minus 2 over x cube under root x square minus 1 dx. So first of all, we have given that 1 to infinity x square minus 2 dx over x cube under root x square minus 1. So first of all, take x square minus 1 is equals to u square. Differentiate with respect to x both sides. We get 2x dx is equals to 2u du, and this implies that x dx is equals to u du, and this implies that dx is equals to u over x du. Again, our limit of integration at x equals to 1, u square is equals to 1 square minus 1, that is 0. So u tends to 0. Again, if at x tends to infinity, u square tends to infinity, since x square minus 1 tends to infinity, as x square is always is greater than infinity is more greater than 1. So difference of infinity and 1 is also tends to infinity. So our given, again, we have numerator is x square minus 2. So x square minus 2 can be written as x square minus 1 minus 1. So, and we have taken x square minus 1 is u square. So this is u square minus 1. So our above integration problem reduces to u square minus 1. This is du is dx is equals to du over x, u du over x, and this is x cube again, and this is under root u square. So this implies that, and integration is so 0 to infinity. So this can be written as 0 to infinity u square minus 1 times u du over x raised to power 4, and this is u gets out to be cancelled. So we can write this again, 0 to infinity u square minus 1 du over x raised to power 4, and x, we have taken x square minus u is equals to u square. So x square is equals to u square plus 1. So x raised to power 4 can be written as u square plus 1 whole square. So this is u square plus 1 whole square. Again, we can write this as sum of two integral u in 0 to, sorry, this is 0 to 1. So this is 0 to 1 u square minus 1 over u square plus 1 whole square du, plus this is again, this is 1 to infinity u square minus 1 du over u square plus 1 whole square. If we take u is equals to 1 over t and differentiate with respect to t, this is minus 1 over t square dt. So we can write and take it as I1, and this, and take this integral as I2. So our integral is I is equals to I1 plus I2. And if we substitute this in I2, this is in I2, then we get I2 is equals to I2. We have given I2. So, and as u tends to 1, so 1 over t tends to 1, and this implies t tends to 1. And if u tends to infinity, 1 over t tends to infinity, and this implies t tends to 0. So our limit of integration changes in I2 as from 1 to infinity. So our integration, our limit of integration changes to 1 to 0, and u square, so we have taken u is equals to 1 over t. So this is 1 over t square minus 1, and this is, and du is equals to minus 1 over t square dt, and this is, and this, and over u square 1 over t square plus 1 whole square. So we can write this as if we interchange the limit of integration, then this changes from 0 to 1. This is 1 minus t square over, this is t square again, and this, again this changes to 1 plus t square over square, and this is 1 over t square, again this is t raised to power 4 dt. So this t raised to power 4 gets out to be cancelled, and again this integral changes to I2 is equals to 0 to 1. This is negative of t square minus 1 over 1 plus t square dt. So, and we know that the integral, a definite integration does not depend on the variable So if we take at the place of t u, if we take u at the place of t, then our integration is u square minus 1. This is u square, sorry, this is a square, this is also a square, u square plus 1 whole square, this is du. So what this is, what this is I1. Look at here, this is I1. I1 is us 0 to 1 u square minus 1 u square plus 1 whole square du. So this is I1. So this is minus I1. So and we have, so I2 plus I1 is equals to 0, and I2 plus I1 is what? This is I. So value of our integration is 0. Thus we have calculated the value of this definite, this given definite integration is, given definite integration is 0. Thus 0 is the answer of the given problem. 0 is the answer of the given problem. Thus we have solved the problem. Thank you.